Question 18 says, in an experiment to demonstrate the photoelectric effect, ultraviolet light is incident on a metal plate. Photoelectrons are released from the plate with a maximum speed of 3.51 times 10 to the power 5 meter per second. Calculate the energy of these photoelectrons in eV. So guys, once you have the value of speed, it's expected of you to remember the value of the mass of an electron. Once you have the mass and the speed, you can easily find out the kinetic energy using half mv square. But once you do that, you'll see that the value comes in joule. But the question clearly says to calculate the value in electron volt. How exactly do you do that? Always remember the value in joule divided by 1.6 times 10 to the power minus 19 gives you the value in electron volt. So all you have to do is just divide this value in joule by 1.6 times 10 to the power minus 19. The value comes to 0.35 electron volt. Next part of the question says, the table shows typical values of work function for 4 different metals. So these are the values of work function. The ultraviolet light used in the experiment had a wavelength of 310 nanometer. Deduce which of the metals was most likely to have been used as the metal plate. So if you get a very basic idea of the photoelectric effect, what happens in the photoelectric effect is you have a metal surface and there is an electron on the surface. A photon comes in. If the photon energy is greater than the work function of the metal, the electron is dislodged, electron is emitted, and it is emitted with an energy. What energy does it possess? A kinetic energy. So this metal surface has a work function. So all of this comes from this photon energy. So this is the famous Einstein's photoelectric equation. That is, the energy of the photon is equal to phi plus the kinetic energy. And for this specific question, since the wavelength is given, you can easily find out the energy of the photon using E equals hc by lambda. And for this kinetic energy, you already have the value from the previous question. This is the value of the kinetic energy. So all you have to do is just make phi the subject of the equation. So my very first step would be to calculate the photon energy using E equals to hc by lambda and then make phi the subject of the equation. And once you see the value, you'll see that this value of phi is closest to magnesium. So the metal must be magnesium. For the next part, question says, photoelectrons are only emitted from a given metal surface if the frequency of the incident radiation is above a particular value. Always remember that one photon releases one electron. In other words, you can say each photon only interacts with one electron. So the electron absorbs the energy from the photons. A minimum energy is required for the electron to be emitted. And do you remember energy of the photon in terms of frequency according to E equals to hf? Higher photon energy related to higher frequency. So frequency of radiation has to be above a particular value. Next part of the question says, a student makes the following statement. It does not matter what the value of the work function is for a particular metal. Photoelectrons can always be released if the intensity of light is high enough. Intensity of incident light is high enough. Criticize the student's statement. Of course, the student is wrong in this context because what is intensity? Intensity is the amount of photons arriving each second. So intensity is related to the number of photons arriving per second. And when it comes to photoelectric effect, each photon interacts with each electron. So the intensity also determines the number of photoelectrons that will be released. So intensity is related to the number of photoelectrons per second. But the energy of these electrons but the energy of the photons does not depend on the intensity. Intensity does not affect the energy of the photons or the kinetic energy of the photoelectrons. What do these depend on? The energy of the photons as well as the kinetic energy of the photoelectrons depend on the frequency of light according to E equals hf.